Hey guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question. Check if an array can be divided into pairs whose sum is divisible by k. So in this question, we have given an array, and by using the elements that are present in the array, we have to make a pairs such that the sum of that pairs is divisible by k. Okay. So for example, we have given k as a 10, and this is the array. And now we need to make a pair by using the elements that are present in the array. Okay, now for the 56, our k is 10. For the 56 can be make a pair with 44. Why? Because it is ended at 6 and 56 can be pair with 44. It that 44 is ended at 4. So if we are calculating the sum of these two numbers, 56 and 90, and sum of these two number is 100, and if we are dividing this number with k, then our it should return 0 as a remainder. Okay, 0 as a remainder. So for the 6, for the number that are ended at 6, we need another number that this number can be paired with. It should ended at 44. So 56 can be made pair with 44. For 79, we need a number that are ended with 1. So we can make a pair with 79 with 11. For 82, we can make a pair 82 with 18. We can make a pair 97 with 23, and for this also. So, so for k is 10, how this type of pairs we can make. So for is k is 10, let's talk about for k is 10, what type of pairs can be possible. So if the number is ended at 2, so it can make a pair with another number that should be ended at 8. So it can be 78, 68, 18, 98. So it can be anything. Okay. So when we are talking about first number and it is ended at 2 and our k is 10, because our k is 10, we need to make sure that its sum is divisible by k and its remainder is 0. For 12, it can be make pair with 70. For let's say example 56, for 56 it can be make a pair with the number that are ended with 4. For example 55, it can be make a pair with another number that are ended with 5. For example our number is 23. So for 23, it can be make a pair with the number that are ended with 7. So it should be 28, 27 is also possible. And if we are dividing this number as by 10, so we are dividing this number by 10, it should give us a x value. X value means it should give it is given us a remainder value. So we are dividing 10 and 12 by 10, so it is giving 2 as a remainder. If we are dividing 78, 10 m dividing by 78 by 10, it has giving us k minus x remainder value, that means 8 value. So for this, if we are adding these two, 10n plus 2 plus 10m plus 8, it is 10n plus 10m plus 10. So if we are dividing this number by k, it should give a return it should return us a 0 as a remainder. So what is this? X and k minus x. If our x is 2, and our k minus x, that means 10 minus 2 is 8, then this number needs the number, its remainder is 8. This number needs this type of number that should gives the remainder value as the 8, so it can be make a pair and it should gives a 0 as a remainder value to us. Okay, now let's take example for 7. Okay, for 7, this is the 44. So if we are dividing 44 by 7, so it is 7 into 6, that is 42. 42, and if we are adding 2 into this, so it can make a 44. Okay. So for this 42 and 42 plus 2, So it gives 2 as a remainder for this. So our x is for this number is 2. So another number that it can be make a pair with, so it we need that number's remainder is k minus x. That means k is 7 and it minus x. That so we want a number that's that remainder as a 5. Okay, remainder is 5. So 84. When we are dividing this number by 7, that means 7 into 11, that means 77 plus 5, it gives us 84. Okay, 84. Okay, it gives us 84. So at this point 7n plus x, that x is, and this number is 7n 7m plus k minus x. Okay, k minus x, it gives return remainder is 5. So these two, addition of these two gives us a 7. Now let's talk about for 11. Okay, another example, if our k is 11, if our k is 11, we are dividing this number by 11. It gives 11 into 3, that is 33 plus 3. Okay, it gives us 36. So our x for this number is 3, and we want another number that this number can be paired with, that is k minus x. So k is 11 and it is x is 8. Okay, another number that gives remainder as 8, we want that number. So 85, the number is 85. When we are dividing this number as a by 11, it gives 11 into 7, that is 77 plus 8 plus 8, it gives us 5, 85 number. Okay, for this 11 n plus x, the x is 3, 11 n plus k minus x, that is 8. The addition of these two, that means 11 n plus 11 m is plus 3 plus 8, that means 11. Okay, so these two numbers can make a pair, and when we are dividing this number by 11, it gives 0 as a remainder to us. So our k, for our k, the function k by n and plus x, for this x, and when we are dividing this by k, it should be cancelled. When we are dividing this number as a k, it should be cancelled. This is the k minus x. Okay, x and k minus x, both numbers count we want as a same. Okay, now let's take this example. Okay, this example, and for finding the answer, we are using the unordered we are using the map here. Okay, map, frequency map here. So the frequency map contains remainder versus how many times the remainder are come here. Okay, when we are dividing 77 by 10, the remainder is 7 and count is 1. When we dividing this 22 by 10, the remainder will be 2 and count is 1. 56, remainder 6, count 1. 11, remainder 1, count 1. 45, remainder 1, remainder 5, count 1. 34, remainder 4, count 1. 78, remainder 8, count 1. 29, remainder 9, count 1. 23, remainder 3, count 1. 55, remainder 5 and count is 2. So for this condition, same for the same remainder, we have two counts, that means two numbers that are same as in remainder. Okay, so this is let's take this number as the x. For k is 10, this is x, and this number can make a pair with this number. How? Let's talk about this. This is x minus, k minus x value. This is k minus x value. That means k is 10, x is 7. It gives us 3, and this is a 3. Okay, So this number can make a pair with this number, and both numbers have only one times. Both numbers are in only one times. Now this number can make a pair with this number. 2 can make a pair with 8. 6 can make a pair with 4. 1 can make a pair with 9. And 5 can make a pair with 5. That means 45 can make a pair with 55. So the count of 5 is 2. So it will appear for the 2 times. So it can make a pair with another number that's remainder is also 5. Okay, now let's talk about for 8. Okay, let's talk about for 8. So for this, when we dividing 9 by 8, then our remainder will be 1. Okay, remainder and count. Okay, remainder and count. Remainder is 1 and count is also 1. By 56, remainder will be 0, count is 1. By 25, remainder 1, count will be 2. By 52, remainder is the 4 and count is 1. By 72, 1, 2, 3, 4, 5. 72, 0 as a remainder, count increases the count. For 44, increasing 4 as a remainder and increasing the count. For 80, increasing 0 as a remainder and increasing the count by count of that zeros. We are increasing the frequency of that 0. For 36, for 4 as a remainder, increasing the count. 96, 0 and increasing the count. For 71, 7 as a remainder and count is 1. For the 55, again 7 is a remainder and count is 1, adding count. Okay, for this now our k is 8. So we are taking this number as a x and this number as a k minus x. So x is 1, k minus x is 8 minus 1, that means 7, and both have two counts, equal counts. X have count, that means f of x, and k minus x, okay, k minus x have f dash of x count. So both counts, if the both counts are equal, then we can say that both the numbers that can be pair make a pair with them together. Okay, they can make a pair with one and another. Okay, now let's talk for 0. 0. The numbers that are giving us 0, this number, again this number, 96 and 70. This number can make a pair with this number. This number can make a pair with this number. After that, so these are some conditions. Now if our remainder is 0, then we need a count in even part, even numbers. We need a count in even numbers. If our remainder contains 0, then we need a even number of counts. Even number of counts. Why? Because this number can make a pair with this number. That means this number can make a pair with this number. This number can make a pair with these numbers. Okay. For 4, that means for 4, our k is 8. K is 8 and 4 value, that we can say that it is k by 2. We can say that 4 is the k by 2 value. Okay. It have odd number of counts. So these two numbers can make pair with these two number. With this and for this number, no one is present here. So it gives false as an answer to us. So this is also one condition to have. If our remainder is k by 2, then we also want even number as a count. Okay, even number as a count. If for example it is 60, then we have 4 numbers, so we can make a pair with this and this with this. So these 3 has a condition, then that we need to take care of, that x count should be equals to k minus x count. If it is equal, then we can say that it is true. If these 3 conditions both are equal at a time, both are equal, then we can say that it is true answer. Okay, now Now let's code for it. So let's do a code. Let me do a full screen first, increasing the font size. So for finding the answer, we need a hash map. So the hash map contains first a remainder versus that remainder's count. So initializing the hash map of integer versus integer. Okay, and hash map, new hash map, and this is a syntax for initializing the hash map. Okay, now for finding the remainder and initializing the count as okay, कशाला कशाला बेंचो कशाला वाढवू गरजच नाही ना. So let's start with the code now. Let me do a full screen, increasing the font size. So for finding the answer, we need a hash map. Okay, the hash map contains remainder versus count. The key value is a remainder and value is a count. Okay, so now let's initializing the hash map of integer of integer hash map equals to new hash map. Okay, now for finding the remainder, we need to traverse on the array. So we are using the for each loop and calculating the remainder as value modulo k. Okay, k. So we are checking at this point. At this point, we are checking is our hash map contains is our hash map contains remainder. We are checking that is our hash map contains remainder. If it is, then we are doing something, and if it is not contains first if it is not already present in the hash map, then we are okay, we are putting the remainder and count as 1. If it is not present already, then we are putting remainder versus count as a remainder versus 1. Okay, now if it is already present, then we need to increase the count of that remainder. Okay, we need to increase the count for that remainder. Okay, so at this point, remainder versus hashmap dot get remainder plus 1. Okay, we need to again traverse onto the array for checking that we can make a pair with that number or not. So we are again start with the for each loop, traversing onto the array and finding the remainder again, that is val modulo k. Okay, at this point our main three condition that we are already discussed, that is our remainder. Okay, is our remainder is 0, is our remainder is k by 2, or our remainder, this is remainder, okay, is our x is equals to k minus x. If this condition equals to means both we need, if we are already discussing the approach that if our remainder is 1 and it contains 2, 3 and 4 counts, and our k is 10, for the k is 10, our remainder is 1. Okay, for k is 10, remainder is 1, and again another number that contains other remainder, another remainder number is 9, and that is again that is contains 4 number of times, that is it appears 4 number of times. So we are checking that this is the x, this is the k minus x. Okay, we are checking is this two value contains same number of count. If it is, then we can make a pair with them. Okay, so first condition is our remainder is equal to 0. Second condition, else if is our remainder is equals to k by 2. And the last condition is that the remainder can be anything. Okay, now in the first condition, what we are checking? We are checking that for this number, for 0 and k minus 1, k minus 2, sorry, 0 and k minus 2, we need even number of counts. Even number of counts. So we are checking that is our hashmap dot get, sorry, hashmap dot hashmap dot get remainder modulo 2. If it is not even number of then we are printing system dot out dot println. We are printing false from this point and returning from this point. Okay, after that, let's say uh, our k is 10. For k is 10, our x value is 5 and k minus x value is also 5. Okay, but if our k is 11, then because we are doing the operations in integer, our k by 2 value, its value, k by 2 value is 5, because integer takes always takes the man dot floor value, not the man dot seal value. So its k minus x is 6. So we cannot say that it is a k by 2 k by 2. So for that we need to write this as a 2 into remainder equals to k. 2 into remainder equals to k. If this condition is true, then we want this condition is also true. So if remainder is 0 and if remainder is equal to k by 2, then we want the count of that remainders even numbers. If it is not, then we are printing the false. Now we are checking, is our hashmap dot get remainder is not equals to hashmap dot get k minus remainder. If this condition is true, then again we are printing false from this point and returning. After checking all the conditions, we can easily print the true from this point, println true. Okay, so this is the full code. Let's try to run this code. Let's try to submit it. Will it be running for all the test cases or not? So all the test cases are passed here. Let's okay now at this is the code, this is the first code. At this point we are adding the value into the hash map with the key versus value. That means adding the remainder versus count. Okay, and from this point we are checking with the in the hash map, is the remainder is 0. If it is 0, then we need its count. If it is in even number, that means for 0 we need even number of count. If k by 2 remainder is k by 2, then again we need a even number of count. Okay, if this is true, then we cannot go into this loop, this if statement, and we are passing all the if statement from this point and we are returning true. If this is not true, then we are returning false from this point. Let's see. For this condition we are checking that is x is equal to k minus x, is our x is equal to k minus x. For this let's say for k is 10, for k is 10, our first remainder that we got is okay, let's say x that we got from dividing any number that is present in the array. So first x we got, let's say 4, and the k minus x is also 4. This is a remainder value, not a count. For the 4, sorry, for this is a 6. So if we add these two remainders, then we got 10. If our 4 remainder is present in the hash map at 5 times, then for this also, for the 6 remainder uh, that is also we want to present at a 5 times. If these two present the same count, then we can make a pair with them. Okay, so this is the all the code, and this is the explanation from my side. So I hope you understand the question and the solution of this question. Thank you for watching.